Hi there. On the bench today we have a motor speed controller, and this was brought to me by my friend who blew it up. As usual, he always blows everything up eventually, and then I'm left to fix it. Now, I wouldn't normally bother fixing something like this because I'm sure they're 10 a penny on eBay, but it's might be worth doing it just for the exercise to see how it works. And of course it uses pulse width modulation, and he was using it on a fan to vary the speed of the fan, which is fine for what you want of it, I suppose. And I've been looking around it before I even got to the point of connecting it up, and that's a voltage regulator. That's LM317 popular voltage regulator, so they're obviously regulating the input voltage down to something to run the control circuitry. And over here we have an old favourite. I wonder if it look better with more light. Yeah, so that's an old favourite there, the NE555. I've been doing stuff with 555s probably for 40 years nearly. Lovely little chip, astable, multi-vibrator, bistable, whatever. And what else we got? We got this mystery one here. Don't know what that is. I don't know what it should be needed for. You've got everything else on there you need. You've got obviously 2 power MOSFETs, which I think are N channel. So they'd be actually taking the pulse widths, square wave, and doing all the hard work of switching it onto the motor or the fan or whatever. But the mystery device over there, I can't really see what the need would be for anything else. But and of course they've done the typical thing on these. They've removed the numbers, so you can't tell what they are. But they're going to be a sort of a 40-60 amp MOSFET, aren't they? That's typical of what they'll be using. There are some numbers on this thing, but I can't see it without getting it out. Okay, let's power it up. Got 12 volts on the end of here. 12 volts. No sparks, but it's 12 volts. I've got the current limit set fairly low because it's not driving anything, so it shouldn't draw much current. Let's see what it does. Okay, well, the LED lights up, that's something. First thing I'll do is check the output from the regulator, which I do not know the pinouts on a 317, can't be bothered to look them up. So that says 4.8 volts on my meter, that says 5.6, that says 7.2. Interesting. Who would have thought they'd take the 12 volts straight onto the regulator? And fuse, is the fuse blown? Fuse I don't think is blown. No, it wouldn't be, would it? But anyway, so let's assume the thing works on the 5-ish volts then. Assuming that's working, of course. It's drawing 14 milliamps at the moment, by the way. Now, I don't remember the pin connections on the 555. I think pin 3 is an output. So we can put it on a scope, get the scope to warm up. I should have become prepared for this with the pin outs on a 555. And this is of course your PWM controller potentiometer. So there you go. Right, stick a scope on it. If I can get it onto there. Oh wow, we'll go to the scope in a minute when I adjusted it. Okay, let me just reconfigure. Oh, my bloody camera thing's come loose. I'll fix that in a minute. If I can make it stay still. Right. Okay, let's go to pin 3 on that chip. And we're getting some activity there, which is fairly promising. Time based down, and that says 32 kilohertz. Well, I guess that's okay. Let's change the potentiometer. Well, we're getting a difference in frequency, but I would have been more happy to see a difference in pulse width on those signals. I think I really need to find out what is the output, if I'm definitely on the output. See what... That's the sawtooth on pin 7. Another sawtooth. Pin 1. Pin 2. More sawtooths. And pin 4 is earth, obviously. I'm going to have to find the pin out on that 555. Okay, pin 3 definitely is the output, so that's where we were seeing the pulses, obviously, so get rid of that. And back to the scope. So that's where we're going. There's a varying frequency of pulses. I wonder if the MOSFETs could be blown up. That would, if they're loading the 555, causing that. I'll just check that. Right, I'm just going to check the MOSFETs, see if they're blown. This is on the first one, from gate to drain. Sounds reasonable, not blown up. And gate to source, not blown up. Wow, 573 ohms. It's a bit low, but I don't know what else is connected. Okay, let's do the other one. 8.9 ohms. I don't think that's right. Okay, I don't think that's right. 9.4 ohms. Gate to drain, gate to source, about 9 ohms on that one. So I think I'm going to pull both these MOSFETs out and measure them out of circuit. Okay, I'll get back to you when I've done that. So both MOSFETs are out. Bloody hard to do that because they're bolted onto the heatsink, and that one's impossible to get to unless you take the heatsink out, which has got this really heavy duty soldering. So not an easy job, so I had to leave the heatsink in. This one was easy because it's just got 3 legs and they'll come out. This one I had to get what did I use? Yeah, this screwdriver, and stuff it through there and unscrew it and then desolder it. So let's test these MOSFETs. Oh, they're covered in solder. Right. Go to drain, open circuit, go to source, open circuit. So that one appears to be good, because they usually go short. Go to 8.6 ohms, that's a bad MOSFET. 9 ohms, bad MOSFET. Okay, having got those little bastards out, I could have another look now and see what the waveform looks like. Let's go to the scope again. I haven't got the hang of this new arm. Right, power back on it. It's only drawing 2 milliamps now. Get back onto pin 3. Oh. Funny looking waveform. Okay, I think it is working how it should. I think it might be working as it should. Obviously at that point it's more on 2, 3. It's not going, it's going below 0 as well, which is a bit weird, because the 0 is okay, but it's modulating below 0. Could I be in AC? That's more like it. I was in the AC coupling, so it's all positive, good. And yeah, it's not the best. I guess if it was in that position, then the majority of time you're getting the full 12 volts or the full turn on for the MOSFET with only a brief turn off time. And if I did it the other way, yeah, can't say it's much different, but I'm sure it is working at 555. So I think the thing to do is probably get a couple of new MOSFETs in there if I can find any, because as I said, they've done their best to conceal the identity of these. Let's see what I got in my MOSFET drawer. So I found a couple of unused IRF 540N. So according to the data sheet on those, they are N channel, 33 amp, 100 volt, 0.04 ohms, which I think's probably good enough because they're in parallel anyway. So let's try those. I think I'll stick them on the top of the board to begin with, and I'll stick them on this side if I can get the so that'll be gate, drain, source, and source is negative. So stick them on the top side of the board before installing them, because it's a tremendous hassle to get them out. So I'll just go ahead and solder them in. So I put those on the board just for testing, and I've got a fan here and it's running flat out, and it doesn't make the slightest difference what I do with the speed control. So that doesn't bloody work, does it? So I wonder if that 555's suffered some damage, because you know, looking at the scope, on the output of the 555, we're just getting mostly pure DC driving those MOSFETs. It's only a tiny spike when it switches off, and varying the speed or the pulse width. The pulse width is not changing, is it? It's just changing the frequency, which is not what you want. So those MOSFETs are being turned on all the time basically, apart from this little time period. Which is what are we on? 500 nanoseconds. They're only turning off for 500 nanoseconds. Well, that's no bloody good, is it? So I think it's back to the drawing board. Get the M555 out and stick a new one in if I've got one. Well, new second-hand MOSFET, not MOSFET, 555 in there, and it's doing exactly the same as it did before. Back to the scope. Get the camera on the scope. See, variable frequency but no variable pulse width. Most strange. So what's causing that then? The other thing I can see near the 555 is a diode. Could check that, I suppose. So I can't find anything else wrong with this thing. So it almost does work though. I mean, if I gradually turn this pot down, when you get to the right at the end of the pot, it is varying the speed a bit. I mean, that's down to very low speed, but it's just such a minute adjustment before it starts to take off. Turn it up again. And then it's flat out again. Then down to the minimum. I'm looking at the scope as I do this, and the DC level drops down. But back to the scope, for whatever purpose it will serve. That's flat out now. Gradually the DC level will drop off. So you can see the average level is definitely going down, but that's not pulse width modulation as I know it. But I can't, that must be how this thing works. If it is, it's very poorly designed, because you only get a fraction of a turn, a fraction of a minute thing before it starts up again at high speed. Anyway, play with it some more with someone else. I'm fed up with it. Bloody thing's useless. So, my conclusion is, this circuit is a waste of space. It doesn't work properly. I can't find anything wrong with it. I don't think it ever worked properly as a PWM. So, whoever designed it hadn't got a clue what they were doing. But I found an alternative, which, if I can get it to fit in, got this off the internet, and it is PWM DC motor speed controller, which is exactly what we want. And as far as I can see, I've got every component I need on the board apart from an extra diode, which they've obviously missed off. I've even got a 1K. Looks a bit complicated, this, because everything inside the dotted line is the 555, but so you can ignore all that inside. We don't need to know what's going on inside the 555. We just need to modify the board, and shouldn't be too hard. Even got a 100k pot, like they suggest. No value for the capacitor, but I don't think it's too critical. As long as it oscillates at some frequency, that's all we need to do. So here we are. We've got the diode there. Need another diode. We've got the 1K there, and these are the two capacitors. These two capacitors are the timing components. They're wired in series for some reason. So we'll see how they work out for the oscillation frequency. So I'll go ahead and modify it. Okay, here's the result of the modifications. An extra diode in there, and a few bodge wires, and I had to put a 12k resistor in series in one side of the pot, because otherwise I was just not getting enough variation. All the control was up one end of the pot, but now seems to work fairly well. Let's look at it on the scope. Okay, there it is. I'm looking at the output on the pin 3 of the 555. And that's with it going absolutely flat out. As you can see, we've got more or less pure DC with a bit of a whatever. If I vary the pot, then you can see gradually we're getting a different mark space ratio, and if you look at the RMS voltage, 6.4, the average sort of voltage will gradually come down as you vary the pulse width, and you can go all the way right out to there. It's down to 1 point, so it doesn't go off completely, but then again this fan stops running. If we go over to the fan, need more light. So that's flat out, obviously, and you can gradually turn the fan speed down, and that's about 50% duty cycle on the output from the 555. The thing about these fans is, if you go too narrow duty cycle, they just stop working. It's still going, only just, and that's just under 50%. It's just not enough energy there to run it. But I think that's better than it was anyway. Certainly it seems to work a lot better. And the only thing I've got to do is tidy this mess up a bit, because it's a bit how you doing, isn't it? Put some sealant over it, I guess, something like that. Okay, thanks for watching, if you did. Bye for now.